Hello everyone, welcome to Homework Help. You can support the channel by becoming a member using the join button. In this video, we'll solve this word problem using the concepts of continuous exponential growth. As per the problem, a researcher puts 300 bacteria in a petri dish. 4 hours later, there are 800 bacteria in the dish. In part 1, we have to calculate the growth rate constant. A petri dish is a small bowl that is used in experiments in labs. Let's start with part 1. We have to calculate the growth rate constant. For that, we have to use the equation for continuous exponential growth model. The equation is A equals A naught times e to the power kt. In this equation, A represents the final amount or number. A naught represents the initial amount or number. E is Euler's number. It's a constant. K is growth rate constant. T is the time period. The situation described in the problem is a case of growth because the number of bacteria are increasing with time. Different teachers use different letters for this equation for continuous exponential growth model, but the term definitions stay the same. In part 1, we have to calculate the growth rate constant. That means we have to find the value of K. As per the problem, the researcher starts with 300 bacteria. So the initial amount is 300. So A naught is equal to 300. The final amount after 4 hours is 800. So A equals 800. T is equal to 4 hours. We should sub in these values in the equation to find the value of K. We have to solve this equation to find the value of K. K is in the exponent on E. The first step is to get rid of the 300 with E. We should divide both sides by 300. 800 over 300 can be reduced to just 8 over 3. In the exponent, K times 4 is 4K. Next, we should use logarithms to bring K down from the exponent level. For that, we should apply log to both sides. As per the power law of logarithms, we can move the exponent 4K to the front of the term on the right side. Next, we can divide both sides by log E. The log E on the right side get cancelled out. Next, we can use our calculator to evaluate log 8 over 3 divided by log E. Log 8 over 3 is equal to 0.425968732 and log E is equal to 0.43 42,944,81. Now we can divide these decimal numbers. I get 0.98083 rounded to 5 decimal places equals 4k. Next, we can isolate k in this equation by dividing both sides by 4. The 4's on the right side get cancelled out. I get 0.2452 rounded to 4 decimal places. Since k represents growth rate constant, we should write the answer for k in percent. So we should multiply 0.2452 by 100. So k is equal to 24.52%. So this is the growth rate per hour for the bacteria. Now we can answer part 2. Write an equation to represent the continuous exponential growth model. We should use the general equation from part 1 to write the equation for this growth model. We should sub in A naught as 300, the initial number, and we should sub in K as 0.2452, the growth rate constant in decimal form. This is an important concept we need to understand and memorize. So the equation is A equals 300 times e to the power 0.2452 t. This should be the final answer for part 2. Now we can answer part 3. Calculate the number of bacteria after 24 hours. For part 3, we should use the growth model equation from part 2 and sub in T as 24 in the equation. We have to calculate the value of A, the number of bacteria after 24 hours. In the exponent on E, 0.2452 times 24 is equal to 5.8848. Next, we can evaluate e to the power 5.8848. I get 359.5309. I'm rounding the answer to 4 decimal places. Next, we can multiply these two numbers. I get 107,859.27. Since bacteria can only exist in whole numbers, we should round this answer. The rounding can depend on the given rounding instruction. I will round down in this case. So the number of bacteria should be 107,859. 107,859 bacteria. This is the number of bacteria after 24 hours. This should be the final answer for part 3. So these are the steps you have to keep in mind to solve this problem. I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.